Fazira Nabila binti Nazri, and my student ID is 2022896034. And my partner is Nurul Fazil Amini binti Adnan, which her student ID is 2022487044. So what is equilibrium? Before we get to know what equilibrium is, we need to know what is a force. A force is a vector quantity, which means that it has a magnitude and a direction associated with it. So move to the definition of equilibrium. Equilibrium is object or systems that are in equilibrium have no net force and no net torque acting on them. This means that the motion of objects in equilibrium will not change with time, and they will also keep the same amount of energy. In other words, the resultant or sum of vector is equal to 0.
Lami's theorem. It states that if three forces acting at a point are in equilibrium, each force is proportional to the sine of the angle between the other two forces. Next, can be applied in three forces only. So, formula used in theorem is sine and cosine rule. Next, for more than three forces in equilibrium, when it involves more than three forces which is in equilibrium, the best way to solve it is by resolve the force into two components. Since the system is in equilibrium, the resultant force acting in any direction is 0. So, the formula is x and y component equal to 0.
So the next one is topic objective. The first objective is to find the value of tension based on the given value. The second objective is to identify the magnitude of each process by using cosine rule. And the last objective is to determine the angle for each side using the sine rule. Question 1. A body of weight 50 Newton is supported in equilibrium by two light and extensible springs. The tensions in the spring are 8 Newton and 2 Newton. The angles of the two tensions with the upward vertical are 70 degrees and theta respectively. Using the triangle of forces, find A the value of T, B the value of theta. Okay, so the first step that we need to do is to sketch the diagram based on the question above. So if we sketch the diagram, we can understand the question better. After that, we can find A, the value of T. So we know that we have the angle for the opposite side T. So so we can use cosine rule. So A, by using cosine rule, which A squared equal to B squared plus C squared minus 2BC cos A. So we substitute the value based on the question given. C squared equals to C squared equal to 13 squared plus 8 squared minus 2 times 13 times 8 and times cos 70. And then we got the value of C squared, which is 161.8598. So if we want the value of T, so we square root the value that we got earlier. So we got 12.7224 units for the value of T. And for the B, we want the value of theta. So we can use sine rule. The formula of the sine rule is A over sine A equal to B over the sine B. So we substitute the number 13 over sine in bracket 180 minus theta equal to 12.7224 over sine 70. So we can move places, and then we got 180 minus theta equal to sine inverse 13 sine 70 over 12.7224. Then we solve the equation, and then we got theta equal to 106.2199.
Question 2. The diagram in figure 3 shows a particle of mass 5 kg that is attached to the lower end of an inextensible string. The upper end of the string is fixed. A horizontal force of 18 Newton and an upward vertical force of 3 Newton act upon the particle, which is in equilibrium with the string, making an angle theta with the vertical. Sum of Fy equal to 0. 3g minus mg equal to 0. 3g equal to mg. 3g equal to 5 times 9.81. 3g equal to 49.05. Therefore, g equal to 16.35. For question A, calculate the tension. By cosine rule, A square equal to B square plus C square minus 2BC cos A. So, we substitute in the formula. T square equal to 18 square plus 49.05 square minus 2 times 18 times 49.05 times cos 19. T square equal to 2729.9025. Therefore, T equal to 52.2485 Newton. Question B. Calculate the angle theta. So, by sine rule, A over sine A equal to B over sine B. So, we substitute in the formula. 52.2485 over sine 19 equal to 18 over sine theta. Sine theta equal to 0.3445. Therefore, theta equal to 20.1517 degree.
Question 3. A mass of 6 kg is suspended in equilibrium by two like inextensible strings which make angle of 40 degrees and 60 degrees as shown in figure 3. Calculate the tension in both strings S and C by using Lamb's theorem. So the first step is to sketch the diagram that's on the figure 3. But we don't know the value of mt, so we can, but it is given in the question, so we can substitute the value, which is mass times the gravitational force. So we substitute the value, 6 times 9.81 equal to 58.86 Newton. So first one, we want to find the string C, the tension of string C. So using the sine rule, we substitute the value. C over sine 30 equal to 58.86 over sine 18. So we got C, which is equal to 29.8840 Newton. Next, the next one, we want to find the tension of S. So we want to first we want to find the angle of S. So 180 minus 18 minus 30, we got 70 degrees. So using sine rule, we can find the tension of S, which is S over sine 70 equal to 58.86 over sine 18. So we got the tension of S is 56.1636 Newton.
Question 4. The diagram below is under the action of three forces of 20 Newton, 18 Newton and 5 Newton. Thus, determine the magnitude and direction of the force F so that the diagram below is in equilibrium. So, solution for this question is, first, create the table vectors S and Y like the table in the slide. After that, sum of Fs equal to 0, 0 plus minus 18 cos 30 plus 5 cos 60 plus F cos theta equal to 0. Therefore, f cos theta 13.0885, and then sum of fy equal to 0, 20 plus negative 18 sin 30 plus minus 5 sin 60 plus negative f sin theta equal to 0. Therefore, f sin theta equal to 6.6699. Next, substitute in the formula. F sin theta over f cos theta equal to 6.6699 over 13.0885. Tan theta equal to 0.5096. Therefore, theta equal to 27 degree. After that, f cos theta equal to 13.0885. F cos 27 equal to 13.0885. F equal to 13.0885 over cos 27. Therefore, the answer is 14.6896 Newton. Last but not least, the conclusion for this topic is equilibrium is the state of an object in which all the forces acting upon it are balanced. Drawing the force acting upon an object, trigonometric functions can be utilized to determine the horizontal and vertical components of each force. If at equilibrium, then all the vertical components must balance and all the horizontal components must balance. So, understanding and applying the principles of equilibrium is essential for ensuring the safety, stability, and proper functioning of a wide variety of systems.